Hello guys, welcome back to another walkthrough, and for today we are specifically going to deal with the USB forensics challenge. Right, so um, USB drives, as we all know, are um, one of the easiest ways or methods that perhaps an attacker, or let's say an insider, could exfiltrate data or important information from a company or from um, a system. Okay, so what we are basically going to do is to solve this challenge today. So forensically, once you are able to acquire an artifact, okay, and analyze a USB device or usage on a Windows system, we can't be able to um, build a forensic timeline on perhaps when the USB drive was connected to the system, what was, which kind of files were interacted with, when was the USB drive removed from the system, anything with regards to that. So we are able to build that timeline even if the USB drive is no more connected to the system. Okay, so uh, let's see what we have here. So let me first have this. Okay, so in this challenge, um, it says that you are a digital forensics and incident response analyst working for a large enterprise. A recent data breach has severely impacted the organization, raising concerns about potential exposure of sensitive information and reputational damage. Our task here is to investigate a potential or a suspected endpoint involved in the incident. Triage data from this system has been collected and then handed over to you, or let me say to us, for analysis. So our main objective is to examine the evidence, um, uncover signs of unauthorized access or data exfiltration. So once it's a USB forensics case, probably data was exfiltrated via a USB device. Okay. Then we have to determine the root cause of the leak. We have our Let me first connect the lab environment because I think this takes some time before it finally bounces. Okay, so whilst that loads up, I would quickly copy the scenario, um, my documentation. So we have it here. Okay, so basically we have the scenario also here. So what you are going to do is to use this as a point of reference. Okay, so in case we come across any timestamps of interest, we could use that to build on the forensic timeline. So we can't be able to document it and then refer to it as and when we really have to refer to it, right? So that's just the reason for this. And let's go back to see if so it's still spawning. So I don't know, I think I don't want the video to be so long, but I would skip the loading part so that I return when it's done loading. Right, so the lab environment has been found now. Okay, so what I'm going to do is to so what I'm going to do now is to RDP into the machine, but before that, let me extend the time so that it doesn't uh, terminate whilst I do not know, because I'm going to RDP into it. So I specify the username that's lit. So now this is the connection into the system. So we have our challenge file over here. Let's open to see what we got. So it's likely this challenge involves a payroll leak. Okay, so that's what we are going to be investigating. So let me unzip it or extract whatever it's contained within the zip file. Okay. Let's also look at some tools that we have. So I think we have a couple of tools, yes, but we are basically going to rely on Eric's. Eric got some tools that really helps in forensics at like looking at it in a general scale, right? But I think that's um good for now. So what I'm going to do is to go back to its defense platform, then now look at what we got for the questions. Let me zoom in a bit. So the first question says, when was the USB device first connected? Okay, and we have our formats to this way. So before we can be able to identify when a USB device was connected to the system, we first need to understand where we would look for information regarding USB devices that were connected to the system. Okay, so that's when the system hive comes in. Let me go back to our RDP, and so basically we are going to check um, let me see, within this folder, Windows system 32 in the configuration. And yes, so basically what is going to help us would be the system uh, hive. Okay, because once we get this from the acquisition file we have over here, we can't be able to open it, but we are not going to rely on the native registry editor. Okay, we are going to use registry explorer to open the system file. So let me open the tools, see Eric, registry explorer. Then we can open this. Okay, it's starting now. Okay, so this is the interface you see once you've loaded registry explorer. What we are going to do will be to load the system hive that would give us that information from the USB store key. So when I get there, I would explain what that means, right? So let's open our challenge file, payroll leak investigation, folder C, Windows system 32 config. Then we select our system hive file, right? Then open it. Dirty hive. So the way to prevent this from happening, it would be to make sure that you have shift pressed. Okay, but you have to hold shift before loading the hive. So I'm going to click on no again, and then reload the hive at this time while keeping my finger on shift. Okay, and I now open it, then click on OK. So we now have our system hive loaded into Registry Explorer. This is going to help us to locate the specific key, okay, that holds information about external storage media. So we are basically going to open up this specific folder, that's the root. Let me try and then expand this. Okay, I think this is still how you are going to see it, right? So once you've expanded the root file, we are going to expand control set 001, which contains this sub folder enum. Then we are just going to look at, so you can see over here we have the USB key, we also have the USB store key. So don't get confused about these two keys. Okay, the one we are going to rely on that will give us information about external storage media such as USB drives that were connected to the system is the USB store key. Okay, what the USB key does is it covers all connected devices or USB connected devices. So think of your mouse, your keyboard. Okay, it covers all of that. But if you want USB specific related activity, so at what time was this USB device connected to this device, I'm going to look into this USB store key. Okay, I'm going to hit on that, and let me try and then bring this closer so you can see what information it gives us. Okay, so you can see the timestamp, you have the manufacturer, the title, you have the version, and a whole lot of information. Right now, let me minimize this, go back to the question. So they specifically want the timestamp at which the USB drive or the USB device was connected. So we are not yet done. Okay, we would need to actually expand the USB store key to find sub keys within it. Okay, yeah, but we are going to also expand this, and this set of characters that you see here is the serial ID. Okay, that's the serial ID. We are also going to expand that, and we are going to look into the properties. Okay, now looking at the properties, what we are really interested in here is the property that starts with H3DA. Okay, going, so that's what is going to give us the information that we need about USB devices that are connected to the system. Okay, so I expand this. Okay, so after expanding this, we can see there are a lot of sub keys. Okay, under this specific sub key we have over here, we have 003, 000A, 0064, 005, and then 66. Now what is contained within these sub keys is, or let me try and then go straight to the point. Okay, so we are just going to look at the sub key that contains timestamp information when the USB drive was connected to the device, and then that which contains the timestamp for when the USB device was removed from the system. Okay, so if you want the exact timestamp of connection to the system, you're going to look at this specific folder, that's 0064. Okay, so let me hit that, and under the data column we have the value to be what 15th August or July, sorry, 15th July 2024 at around 3:36 a.m. I'm quite sure that this is in UTC. So I think this is the exact value that we need. Okay, so I'm going to copy that, I'm going to copy that, go back to Let's Defend and put that in. So let's verify if the format is right. Okay, so the format is right. Let's submit. Right. So let's move on to the next question. What is the serial number assigned to the USB device? So I told you earlier on that for the serial number, that's the first subkey under, or let me say, um, uh, after expanding the USB store key, okay, you now have access to this specific, folder that tells you uh, the product code. Okay, now we expand that as well and then look at this specific folder. So once we click on that, we have a lot of values within it. We have values such as the friendly name. Okay, so we have the friendly name over here, and we have a whole lot of information such as the GUID. Okay, and these are various information that would help us, okay, be able to um, build a good forensic timeline. Okay, because information that we find over here right now can or may be able to help us in the subsequent questions that we might be asked. Okay, so let's just copy this. So I'm going to so this is the serial ID. Okay, so I'm going to right click, but it doesn't work that way. Yes, then I'm going to copy. This is very slow. Then I'm going to copy the key name. Okay, so we have it. Then go back and then submit that. Really, do I have a space here? Wow, let me move it and look at the format. So the answer format says, wow, let me go back, then verify. What do we have missing? What do we have missing? It's supposed to be this, so why the exact key? Oh, okay, I get why. So we can see over here, but let me kind of right click it at this point. You can see over here that the value we have here, okay, contains symbol before the 0. Okay, but when we right click it to look at the exact key, we could see that there was no symbol within the key value. Okay, so what I'm going to do is to go back to Let's Defend, and then now remove the symbol. Okay, then I submit. Wow, it's still not working. What is the serial number assigned to USB? Let me try adding it back, giving a space over here. It didn't work. Wow, this is really expand it. We still have this same key containing the hardware ID, the various GUID. So why isn't this working? Just copy it if it works out. So not working out. Wow. Let's check Let's check the hint. So it says that look for the serial number field at this specific in the system registry hive. Omit the end parameter and any values after. Oh, okay, okay, okay. So I see why it didn't work out. Okay, so we need to omit this parameters. Okay, so any parameter after the after this symbol, okay, we need to remove it. So let me enter. Okay, so that was the right approach. Okay, so the third question asks us that what volume drive letter was assigned to the USB drive. Okay, so right now we are shifting from right now we already know the timestamp at which the USB drive was connected. We've gotten the serial number assigned to the USB drive, but now we want to know the USB drive letter. Okay, one thing or one importance of knowing this is that once we have that in mind, okay, it would help us to easily identify more artifacts or more information, evidence relating to the specific investigation that we are working on. Okay, so once we have that specific drive letter, whether A, B, C, D, E, anything of that sort, it will help us to easily identify important information that we might need for this specific event or this specific investigation. Okay, so let's go back to RDP connection, and we are now going to turn our minds off the registry and then rather look at the logs. Okay, we are now going to look at the logs. So let me okay let me and so right now I think we have some logs. Sorry, I should look in the challenge file rather, that is over here. So go back to this specific folder in this app, and so every log data is contained within this specific part. So when event yes, so these are the various logs, but then we are going to look specifically for the NTFS operational logs, okay, because that is where we can't be able to or that is what records, okay, information about the USB drive letter. Okay, it records mounting details in general. And let me just search it. If it so we have that here. So that's what we need. So let's just open the operational log. So basically within this log file, we are just going to look at, or that is where we can be able to get information about mounting details, especially this specific log file. And we are going to even filter for the event ID 142, okay, which in most cases assists or helps security analysts to timestamp when perhaps an external USB drive was connected to a system when it was moved. So this is a sample of what we need to see. So you can see this specific event tells us the summary of the disk space usage, okay, since the last event. Then you can even see the volume name over here. Okay, so let's first filter for the event ID 142. I hit OK, and I think we have about 26 events. Okay, but how do we identify that this is the exact event relating to the investigation that we are working on? Okay, so just for us to get that context, we are going back to Registry Explorer. Okay, and we noted over here, so from This side 0064, that's the sub key over here. That was when that was the timestamp of the initial connection of the USB drive. Okay, we have to keep this in mind. That is around 3:36 a.m. on 15th July. Okay, so 3:36 a.m. 15th July. Then we'll use that to filter for this event. So we are looking for events around 15th July, that's 3:36 a.m. Okay. And looking at this log file, right, you can see there is events on 2nd June. Okay, definitely that is out. So what we are looking for is basically these two events. So I think we have three from 15th July. We have three, but we are basically looking for the exact timestamp. So 36. Okay, so 3:36. This is the most yeah, I think this is the exact events that we are looking for indeed, because this timestamp correlates with the timestamp we found within the registry. Okay, that gives us a summary of the disk space usage, okay, since the last event. This is the exact event that is most uh, it's of the same timestamp, okay, at 3:36 a.m. Okay, looking at this as well, the same timestamp. So we can't be able to use this to confirm that, oh, this is exactly true, or to minimize errors during forensic analysis or investigations. So we've been able to identify that same timestamp over here. But the question is asking us to um, specify the drive letter that was assigned to the USB device. So go back and you can see from here the volume letter name is port E. Okay, but aside that, we have some information about the lowest free space, the highest free space. Okay, so we are able to get much more details that had been recorded in the logs. Okay, that's turning our focus from the registry and then looking at what is contained in the logs, right? So we have the volume name here to be. So let's go back to, let's put that in. Yes, so we got that. Then we need more evidence to confirm the data leak. What was the name of the folder on the USB device where the stolen data was placed by the insider threat? Right now we are moving away from knowing the exact timestamp at which the USB device was connected, removed. Okay, we are shifting our attention from then now trying to look at what exact folder, okay, on the USB device. So this is something that is very should I say, is very good about forensic analysis, because it doesn't care that the USB device is no longer available, or the USB device is no longer plugged into the device, or even the folders that had been interacted with were deleted. Okay, we have what we call, so let me go back to the remote desktop connect. So we have what we call ShellBags. Okay, so ShellBags are basically registry keys, okay, that they store information about you viewing folders. Okay, so, and if you are trying to interact with folders, files, okay, within the GUI. So if, let's say, you open just as I've opened a folder like this, okay, once I'm using the file explorer, okay, ShellBags, it's like they take screenshots of whatever I'm doing. I just want you to get that concept. Okay, so those are what ShellBags do. So they record if you are viewing a folder. So it can help us to also know whenever a user actually browses. So once I open this folder, okay, whatever I do, okay, is recorded in ShellBags. That's the kind of scenario I want to prove over here. Okay, so how do we actually make use of information within ShellBags? Okay, but let me go back and let me see if I can minimize this. Okay, so I think we'll need to use ShellBags Explorer, but before I do that, let me show you this. So basically, the information about ShellBags are stored within let me open the challenge file. So payroll leak investigation, then we'll look into this folder, then we come to the users folder, we come to let's defend, and we have our data, then local Microsoft tools. So this user class dot that file is what, so most of the shellbacks are contained within the specific file you see over here. Another way to see this is, let's say, looking at I'm going to use my main system as an example. So I think registry editor. Okay, I'm going to open this, and so looking at this specific hive, okay, HK current user, then I look at software, browse for Microsoft. Let me increase this. So Microsoft Windows, you have Windows. Then so you have a shell. Okay, so within shell you can see there are two sub keys. That's the bags and then bag MRU. So those are the very various locations where shell bags are stored. Okay, so that is just the representation in terms of the registry location where you can find the shell bags. We are not going to be looking at that. We are just going to work with um, uh, the artifacts that we've been given. So this is the specific file we need, right? But how do we open it? So that is where ShellBags Explorer comes in. Okay, so going back to Eric's tool, let's see ShellBags Explorer, then open this. So this is something or a tool that will help us to easily visualize whatever we have within that user class dot that file. So let's wait before it to load up. Wow, let me just type in anything at anything dot anything dot anything, right? So once it's open, we click on file, then you can either choose to load active registry or load offline hive. But since for this investigation we've been given an artifact to you, we are going to rely on the loading of offline hive. So we are going to use this. Then we specify the exact location of the user class dot that file. So challenge file, payroll leak investigation. In this, go to the user, let's defend, app data, local Microsoft tools. So this is our file, user class dot that file. Then we open it. So it tells us that words parsing has been completed, and then there were 15 shell bags that were found. Okay, we have the root folder, directories, and arrays, and one drive letter. So this is exactly what we need. So once we've been able to identify the drive letter, which is E, okay, through the operational logs, that's the NTFS operational logs, you are now building on that. Okay, investigate further. Okay, I'm going to click on OK, and let's see. So these are just messages, and close this now. And now open. So let's open the PC. Now you have the drive E over here. I'm going to click on it, and we see that it has a value called what? New project hires, new project underscore hires underscore data. So this was a folder, okay, on the drive E. That's the USB drive that we are currently investigating how information had been exfiltrated with it. Okay, so let me expand this specific key, and then look at the new projects has data. So within this folder also contains payroll new hires directory. Okay, this is getting interesting. Here we can't see the exact absolute path. Okay, then we are also seeing the time it was created. Let me bring this up. Time it was modified, the last accessed timestamp, and then even last interacted with timestamp. Let's expand that as well and see. There's also another folder under it. Wow. So up till payroll data one. Okay, so this is, so we are trying to build what the attacker did. Okay, so let me go back to the question and see what exactly they're asking us. So since we need more evidence to confirm the leak, what was the name of the folder on the USB device where stolen data was placed by the insider threat? So I think we can't go with this first one. So that's new project hires data. Let's see. So basically, this was the um, base folder in which this payroll underscore data folder. Okay, basically there could be something over here as well, but at this point we won't be able to see it over here. Perhaps if another question asks us, then we'll use a different approach to identify. I think with that one we can even rely on um, jump lists. Okay, if the question requires us to that. So basically, let me. I think I copied this, right? So go back and paste that in. Submit. Okay. At what time was this folder browsed? So now going back, we need to note down the time at which it was browsed. So I think that would be the last interacted time, or the last time it was interacted with. Okay, so I'm going to copy this, go back and take a look at the format. Okay, so we need a year, month, right? Let me paste that in. You realize that there is no room for milliseconds. We are going to remove that and let's submit. Okay, which tool was used to open the stolen files containing sensitive information? Answer as mentioned in the jump list explorer output. Okay, so basically we are going to utilize jump list explorer to be able to note or identify the specific tool that was used to open the stolen files, okay, that contains the sensitive information. So let me go back and I think we can minimize this now, and we are turning our attention to jump list explorer. Okay, let's open that. So basically jump lists, they provide a quick access to recently used apps, okay, so that we can find file modifications, okay, relating to apps. Okay, so if let's say notepad was used to modify an app, that is what jump lists will help us to identify. Okay, so it's very very much useful in terms of USB forensics. Okay, and also there's a special location where these um, files are stored. So we are going to browse that as also the same way we did for ShellBags. We are going to load the jump list file over here. So you can see it's already telling us these are the automatic destinations. So this location is where we can find the jump list. But mind you, if you are trying to, this specific location is kind of maxed. Okay, so unless you are browsing this exact location, you would never find it on a Windows. Okay, but one thing as well is you have automatic destinations and custom destinations. Okay, so what we are going to do is to load both, right? But before that, let me even try and use my, so within my main system. Okay, this is the location for the jump list. So imagine I remove this. Okay, imagine I remove this and I browse to the recent items. Okay, I browse to the recent items. You see, if I search for automatic, I've not even completed, it tells me that what, no items match my search. You get it? So that is how jump lists work. You will never find that there is a folder. So you can see there is nothing of that sort. But if we add it over here, okay, so we add automatic destinations, right? You see that then it's loading the jump list. Okay, so that is how it works out. You have to know the exact uh, path, okay, for the jump list before you can be able to load it. So I'm going back, and once this has been given, okay, we are first going to load this. That's the automatic destinations. Okay, then I'm going to hit on open. So we have that information over here, and now we would look at let's try to explore what we have over here. So we have the jump list type, that's automatic. We can also choose to import the custom jump list in addition. Okay, but let's first see if the information that we require is already here. Okay, we also have the app ID, the app, ID description. So with this it means that what Notepad, or let me say Notepad is the specific app that was used to open a specific file, right? That's just what it means. So this is how this is the beauty behind the jump list explorer, and the uh, the advantage of it in terms of trying to understand what, or you're trying to build a forensic timeline against a specific events that occurred, or a specific um, events that occurred, right? So looking at the name column over here, okay, we have two entries. That's this entry as well as this entry. And you can see that there is the drive letter name over there, okay, which points to the specific location we found earlier on. So you can see drive E, there is the folder new project hires. Then within that, okay, we have a lot of information, and then now you can see that the exact file that was interacted with was what, let me see, the exact file that was interacted with. Let me try and then bring this bit, okay. Looking at the absolute path, right? uh, I think I need, yes, you can see what employee underscore pi dot csv, right? So basically what jump list is telling us is that the attacker, okay, was able to access this specific employee pi data, or actually exfiltrated this pi data with the USB device. uh, that is what we are being asked of. Okay, ask us of the two. Okay, so clicking on specific applications, okay, filters to specific files that were opened by that specific application, right? So looking at quick access, you can see that there were two entries. Basically this file, that is employees, let me see if I can move this. So employees underscore USD accounts, accounts.csv file was actually open via quick access. Okay, so having seen that, let's look at the properties over here. You can see that the destination list last modified was on what, 15th July 2024 at 3:38 a.m. Okay, looking at this as well. So the time at which the folder was browsed was at 3:37 a.m. Then the specific file that was employees USD account.csv was modified, right? Let's look at for the employee pi, that was also last modified at 3:38 a.m. Okay, so aside quick access, let's look at Notepad as well. With Notepad 2, we can't see that. With Notepad, we can't see that there were two entries. Okay, so clicking on the first one, we have the employees underscore USD accounts.csv file. Okay, so that was also last modified at 3:38 a.m. and this was also done at 3:38 a.m. So we can't say that the specific application that was used, okay, to interact with the files, okay, contained within the specific folder that the attacker accessed on the USB device was Notepad. Let's try and then put that in and see. Um, the two. Looking at the answer format, let's see if it um, correlates. Notepad 64 dash bit. I think that's just it. So Notepad 64 dash bit. So we got that. What is the full path of the file containing the pi data of employees? So we need to find the full path. So we just go back to the connection. So let's see, that's the absolute part over here. So we are looking for the pi. Okay, let me expand. Let's see if we can come out. It's not possible, I think. Let's check. Don't think it's possible. Our last option would be to seems like we are unable to copy the path and would need to type it manually. I think we need to type it manually. So right, so no problem. Let's just at how we can be going to let my screen. Yes. Then we finally have the value at the specific file, that's employee underscore pi.csv. So employee underscore pi.csv. Okay, then we are on our last question. So this is asking us that at what time was the file containing pi data opened by the insider threat? Okay, so we are still looking at the pi data. So with that, we need to look at the exact timestamp that it was opened by the insider. That will be our last modified time. So we have 3:38:07, right? 3:38:07. Let's go back and let me go and copy this of that here. So 3:38. Let me have our 07, for example. Okay. So yes, basically this was the USB forensics challenge, and now we've been able to solve for this. Was quite interesting. Okay, and so thank you very much for staying with me through this challenge, and I would see you in the next. Bye for now.